Today's notes are on solving quadratics by completing the square. What is completing the square? A method used to solve a quadratic equation, an equation with a highest exponent of 2. This method changes the equation into a trinomial that will factor using the perfect square trinomial pattern. Then, you can take the square root and solve. We are going to use this method on any quadratic with x squared and x terms. It is most often used when a quadratic is not factorable from the beginning. The following example takes you through the steps as well as a full example going down the right side. So we're going to talk through example number 1, which has us solve 2x squared plus 12x minus 14 equals 0 using completing the square. Your first step is going to be to isolate the variable terms onto one side. So you're going to move c over. So notice that the 14 was moved to the right side of the equation by adding it to both sides. Then you're going to divide both sides by a to create 1x squared. So you want the number in front of the x squared to be equal to 1. So here's the division. Here is our simplified polynomial. Next, we are going to determine the new c value by taking half of b and then squaring it. So b divided by 2 squared. Right, by doing this, we find that we get an answer of 9. You are going to add 9 to both sides of the equation. It's very important that you add it to both sides, because if you do something to one side of an equation, you have to do it to the other as well. So that now gives us x squared plus 6x plus 9 equals 16. Now I can factor the trinomial to be x plus your b value divided by 2, and then I can rewrite that as a quantity squared. So my b value was 6. If I divide 6 by 2, I get 3. So this whole thing can be written as the quantity x plus 3 squared, and it's still equal to 16. Now that I have a quantity squared on the left side, I can solve the square root on each side by solving for x. Remember to include plus or minus in your answer when you're solving for the variable. So square root of each side, square root of 16 is plus or minus 4. So we're left with x plus 3 equals plus or minus 4. So I'm going to subtract 3 to get x by itself, and then create two separate equations and solve for x. Let's take a look at the next page and actually talk through an example. Right, when solving this problem, the first thing I want to do is isolate the variables on one side. So I want to move the c value over. So we're going to be subtracting 5 from both sides to get 4x squared minus 2x equals 5. Then I'm going to divide both sides by 4 so that I'll have a 1 in front of the x squared. This gives me x squared minus 1/2 x equals 5 over 4, and I'm going to leave them as fractions. Step 3 tells you to determine the new c value by taking half of b and then squaring it. Well, my b value is negative 1/2, so I'm going to take negative 1/2. I'm going to take half of that, and then I'm going to square it. Negative 1/2 divided by 2 gives me negative 1/4, and we're going to square that to get a positive 1 over 16. And we're going to add that value to both sides of the equation. So if I simplify this, I get x squared minus 1/2 x plus 1 over 16 and this is going to be equal to 21 over 16 by adding the two fractions on the right side together. Next, I'm going to factor the trinomial on the left by taking half of the b value. So half of 1/2 is 1/4. So this is going to factor into x minus 1/4, and it's going to be the quantity squared. So I factored everything on the left to the quantity x minus 1/4 squared. Our last step here with step 6 is to square root each side, remembering to include plus or minus in our answer. So I'm going to take the square root of x minus 1/4 squared, and I'm going to take the square root of 21 over 16. This leaves me with x minus 1/4 is equal to plus or minus, and I'm going to break up the radical, square root of 21 over the square root of 16, which I can simplify again to be the square root of 21 over 4. Then I'm going to move the 1/4 to the right side of the equation by adding it. So I get 1/4 plus or minus the square root of 21 over 4. Because both have a denominator of 4, I can leave it like this, or I can put the whole numerator over a single 4. So either one of these would be acceptable answers. We do not have to rewrite it as two equations because we can't simplify them in the same way. If your problem is a word problem, you may want to express your solution as a decimal and only use the positive solution. So if I have x plus is equal to 1 plus the square root of 21 over 4, this will give me the approximate solution 1.349. And if I have x is equal to negative 1 minus square root of 21 over 4, I get x is approximately equal to negative 0.896. Please try practice 1 and 2 on the bottom of the page on your own. We will look at the practice on the third page together tomorrow in class.